So now that we've covered what inverse functions are, we want to talk about various types of inverse functions. So the first type of inverse function that we're going to talk about is the logarithm. First of all, as I think many of you know, we use the term log a of x. This is actually pronounced log base a of x. Specifically, we refer to the a as the base in the same sense that a was the base of an exponential function. So log base a of x is a number y such that a to the y equals x. So in other words, if y equals log base a of x, then a to the y is equal to x. We can think of log base a of x as the inverse function of a to the x. So if we define, right here, if we define f of x is equal to a to the x, then log base a of x is its inverse function, f inverse. And what follows from that is that if I compose these two functions, if I write f of f inverse, if I write f of f inverse, then I should get x, and in fact I do. If you compose f and f inverse, you do get x. So a to the log a to the log base a of x is equal to x. In fact, if I compose them in the other direction, where I start with f inverse on the outside and put f on the inside, then it looks like this. Then it's log base a, because that's the outside, that's the inverse function. Log base a of a to the x is also equal to a to the x. Sorry, is also equal to x. One special type of log that is worth noting is log base e, and because e is such an important number, this is of course the number e that's approximately equal to 2.718. You should all know that. And log base e is so important that it gets its own name, and it gets its own name and symbol. So the symbol is lnx right there. And it's pronounced either ln. You'll usually hear me pronounce it lnx. Some people pronounce it lin. I've even heard it pronounced lawn. I guess it's up to you. I think that ln is probably the most common pronunciation of this. And it's simply, by definition, ln x. It just means log base e of x. It's just a shorthand for this very important logarithm. Logarithms obey certain laws just like exponents do. So these are the laws of logarithms. The first one is for products. Log base a of x times y is equal to log base a of x plus log base a of y. So for example, if I take, let's say, ln of 2 times 3, that equals ln of 2 plus ln of 3. So the next law is for quotient. Log base a of x over y is equal to log base a of x minus log base a of y. These would all apply for ln as well, because that's just log base e. I'm not going to keep writing the ln rule there. It's the same whether I write log base a or ln. The rules are all going to be the same. So rule number 3 is the reciprocal rule. Log base a of 1 over x equals negative log, should have written the base a in there, log base a of x, and log base a of x to the y is equal to y times log base a of x. I should put in a multiplication symbol there. So in fact, let me just be more explicit about what I'm writing. This is y times log base a of x, like that. So you can convince yourselves that these rules are true just by using them in conjunction with exponents. So let's take a look at the green line here with ln of xy. Let's convince ourselves that that ln of xy equals ln x plus ln y. We can do that by simply writing out, let's write it here, example, e to the ln xy. We know that e to the log base e of anything is just that thing, so this is going to equal xy. Well, we also know that I can write x is equal to e to the ln x, and y is equal to e to the ln y. In general, by the way, this is a very important operation in calculus. You should be able to write any number. Like if I have 205, it should immediately come to your mind that this is equal to e to the ln 205. That's just how natural logs work. So, and it becomes useful to be able to do that. So anyway, so this, I'm just going to write it, and I'm going to erase this and just put it in line. This is equal to e to the ln x times e to the ln y, because this is equal to x and this is equal to y. So therefore, by the law of exponents, where if I take a common base and I multiply two things raised to that same base, I can add the exponents. This is going to be e to the ln x plus ln y. So I have these expressions are equal, and we recall from a previous discussion that if I have the same base raised to two different expressions, if they're equal, they must be equal. If you recall, the rule was that b to the x equals b to the y implies that x equals y. So that's exactly what I have here. I have e to the ln xy equals e to the ln x plus e to the ln y, which implies that these two expressions must be equal to each other. And you can do the same sort of calculation for any of these rules to convince yourself that they're true, but the most important thing is, in order to do math at this level, you really just need to know these rules cold. By the way, I just want to just demonstrate to you one of the most important mistakes that people make. I see this all the time. Um, Many people will write that ln2 over ln3 is equal to ln2 minus ln3 in kind of a misapplication of rule number 2. This is not true. The correct thing to say, the correct thing to say would be that ln of 2 over 3 equals ln2 minus ln3. This particular expression doesn't simplify to anything. There's no particular rule for a quotient of two logs other than change of base, which we'll get to in a minute.